Hello all. In this session, we are going to learn how to get the yield stress on the stress strain graph by 0.2% offset line method. In some material, it is difficult to determine yield point on the stress strain curve. In such a case, offset yield point is taken as stress at which 0.2% plastic deformation occurs. It means at 0.2% straight line is drawn parallel to the elastic curve which follows the Hooke's law of the material, and point at which this straight line cuts the curve, that is intersection point between the line and that curve, is considered as yield point for that material. This method is generally followed for the ductile materials like, for example, aluminum. Let's see how to do this. Here I have taken stress strain data for aluminum 6061. First step is to plot this data on the graph. Select the full data. Then go to the insert and select smooth curve. Here is the stress strain graph for this data. Now we have to plot offset strain on this graph. Now in this offset strain column, put the formula like equal to strain plus 0.002, that is 0.2%, and drag this up to the end. Now for offset stress, copy the same stress column, that is put the formula equal to that column, then enter. Drag this again up to the end. Now we have to plot this offset stress and strain on this graph. For that, go to the graph, then select data, then add a data. Suppose we have to add a new 0.2% offset graph. Give its name. For X series, we have to select a data of strain. I will take for until the end. For Y, select stress. Then OK. Then OK. This data is parallel to that blue line, that is original stress strain curve. But for finding the yield point, we need intersection of the elastic curve of this offset with that original curve. For that, we have to cut this red line up to only up to the elastic limit, anywhere. So I will only keep the linear portion of the line and delete all the points after that. For that, suppose I will take 260 as limit. I will cut or delete the points below 260 stress, that is, suppose like I will delete from here. Now I have only kept the straight line, that is linear line, and now we have to extend this line in such a way that it should cut this blue line, and so that the point of intersection is the yield point of this aluminum. For doing this, first we have to calculate Young's modulus of this material, that is the slope of the line in the elastic region. I have already calculated the Young's modulus for the material as the slope of the line by the formula, that is y2 minus y1 upon x2 minus x1. It is around 61,820 MPa. For y2 I have taken value like y2 on the stress, y2 minus y1, and suppose x2 is the strain minus the strain. You can take any value that will give us the Young's modulus, the slope of the line, and that is 61820 MPa. In this graph I have stopped at this point. Suppose I will park, and after this point we have to go linearly, we have to go straight line for the intersection, and for that we have to put the formula over here. We know that is the Young's modulus is a stress upon strain, and we need the stress value after this 260 value. Suppose stress is equal to Young's modulus into strain, that is 61820 into 61820 into the strain, that is original strain, and then enter. Now you can drag it up to some points, suppose like this. Now we have get the line which is intersecting the curve, and the point of intersection is a yield point of this aluminum, that is suppose 275 for this aluminum. In this way you can find the yield point by 0.2% offset method.